For this problem, we want to verify that secant squared x times the quantity of sine cubed x minus sine x equals negative sine x. Notice that it says just verify, which means we can only use one side. So, we always want to start by picking the more complicated side. So this left side is obviously much more complicated. It'll be easier to work with. The first thing that we can do to start off this problem is notice that we have a secant squared x multiplied to the outside of our parentheses. Let's change that to its reciprocal identity. So secant squared x is the same thing as 1 over cosine squared x times sine cubed x minus sine x. From there, we are multiplying this sine cubed x minus sine x by a fraction. So let's go ahead and make this quantity over here a fraction also by putting it over 1. And when we do that, we are now multiplying two fractions together, so we can just multiply straight across. That gives us sine cubed x minus sine x all over cosine squared x. Now this wasn't a step that you had to show, this intermediate step here. Whenever you have secant multiplied to anything, you can just put cosine into the denominator of whatever it's being multiplied to. But this step shows what's actually happening with that. Now that we're here, now that we've changed this to cosine squared x, the next thing that we should consider doing is factoring. The first two things that you should always try to do whenever you're verifying an identity is either factor or multiply, or deal with your Pythagorean identities. So in this case, notice that we can factor out a sine x from each of these terms in the numerator. So let's go ahead and do that. That'll give us sine x times sine squared x minus 1 when we divide each of these terms by sine x, all over cosine squared x. And now from here, sine squared x minus 1, that looks very similar to one of our Pythagorean identities. So we'll go ahead and show this off to the side. Remember, we always want to show our Pythagorean identities off to the side if we use them. So we recall that sine squared x plus cosine squared x is equal to 1. And if we want to get this sine squared x minus 1, then in order to do that, we would have to subtract 1 from each side, giving us sine squared x minus 1 plus cosine squared x equals 0. And then to get the sine squared x minus 1 completely alone, we would then have to subtract cosine squared x from each side, giving us sine squared x minus 1 equals negative cosine squared x. That means we can now substitute that into our problem. This sine squared x minus 1 can be replaced with negative cosine squared x, leaving us with sine x times times negative cosine squared x all over cosine squared x. And now at this point, we have a common cosine squared x on the top and bottom of our fraction, which means we can cancel it out since we are only multiplying and dividing in this fraction. So the cosine squared x's go away, leaving us with negative times sine x is negative sine x. And that is exactly what we were looking for when we originally started the problem. So we'll write it on our right side as well. And then put a filled in box to say that we have verified the identity.